In this problem, we are going to find the distance between x1, y1, z1 and the point x2, y2, z2. We can first think of this in a 2D perspective. In the Cartesian plane, also known as the 2D coordinate plane, to find the distance between 2 points, we use a distance formula, which is derived from the right triangle's Pythagorean theorem. And for the 3D plane, instead of just constructing right triangles, we have to construct 3D shapes first. For example, rectangular prisms. But first, we can draw the 2 points. So we can call this point as a x1, y1, z1. Then we can call this point as b x2, y2, z2. Now, to construct a rectangular prism, first, we think about the 3D coordinate plane. There's 3 axes, x, y, and z axis. So if we just construct it, well, this rectangular prism is not directly on the coordinate plane. So instead of just drawing the axes, we can just draw the sides. But still keep the axes in mind, because you will need them. So we can just construct sides based off the coordinates. And then the edges are parallel to the coordinate axis. So we'll just draw the sides of the rectangular prism. After we draw the rectangular prism, we can mark these points as C and D. So A and B are just the 2 opposite vertices on the rectangular prism. Then, we can use the coordinates to find out the measures of AD, CD, and BC, because our final goal will be to find the length of AB. But then to find AB, well, we notice that if we draw the other lines in a rectangular prism, they are not shown in the dotted lines. Then, we realize that after connecting BD, AD is perpendicular to BD because it is perpendicular to the surface. So, AB will equal to the square root of AD squared plus BD squared by the Pythagorean theorem. To represent AD, it will just equal to the absolute value of z1 minus z2. We say absolute value because we want the distance to be positive. To find BD, we'll need to find BC and CD because, once again, in the right triangle BCD, BD equals to the square root of BC squared plus CD squared. To find CD, it will equal to x2 minus the absolute value of x1 minus x2. Then, for BC, it will equal to the absolute value of y1 minus y2. Then, just apply the Pythagorean theorem. So, AB equals to the square root of AD squared plus BD squared. So, this will equal to the square root of AD equals to AD squared equals to C1 minus Z2. We remove the absolute value because perfect squares are always positive. So, plus BD squared. And this will equal to square root of z1 minus z2 squared plus x1 minus x2 squared plus y1 minus y2 squared. Okay, so now we have derived the formula, the distance formula for the 3D coordinate plane.